Beginning with the fundamental design of the building core, the rudimentary elements that make up the core are as follows: the elevator lobby, the passenger elevators, the service elevator, fire and electrical ducts, the fire escape elevator, fire escape washrooms and washrooms. Their spatial allocations have been color-coded respectively. Considering designs of high-rise structures, the types of core systems that can be set up are central core, a single and double split core, a single and double exterior core, and finally an offset core. A central core system has been inculcated in our design. Out of the 5 elevator grouping systems listed down to right, a 4-car grouping system has been set up in our design. Moving on to the ideations in form development which have led to development in our design. All the 4 ideation forms comprise a rotational component along the longitudinal axis and majorly vary in the magnitudes of rotation. The first form comprises of a rotated component by 4.5 degrees on every single floor, following a continuous progression. On the other hand, the second form comprises of a rotated component by 2.25 degrees after an interval of 5 floors each. The third form comprises of 2 separate branches with each floor being rotated by an angle of 2.5 degrees, with both the branches revolving around a central core. The fourth and the final ideation comprises of 4 separate branches revolving around a central cylindrical core, wherein each floor rotates by an angle of 0.75 degrees. From these 4 ideations, the inference procured turns out to be that smaller the magnitude of rotation of each floor or a set of floors, more stable the skeletal system of the structure stands. With the floor plates rotating forming a continuous progression around a stable central core, provides the most scope for a structure to be stable. From the processes followed in the previous 4 ideations, the final form zeroes down to have a rotational magnitude of 0.6 degrees for each floor. With 4 different branches, revolving around a central octagonal core, the skeletal structural framework has been displayed towards the right-hand side. Moving on to the design of the central core of the building, the requirements that we have looked at are as follows: rigidity to the core, 1. Concrete shear wall, lift and staircase walls, 2. Concrete mega columns, 3. Mega columns anchored to each other by outrigger beams and belt truss of steel, 4. Provide additional rigidity, introducing bracing members as diagonals of steel, 5. Anchoring the external function branches by radical trusses of steel. 6. Each floor to be braced by diagonal members from the underside to the curved outrigger beam, 7. Bracing to be of steel and the external curved outrigger to be of concrete, 8. Additional of external steel spine along the curvature as it being a gradual change of 0.6 degrees. Moving on to the construction sequence of the building. To the left is a representation of an axonometric view of the structure as a whole, which is then followed by the axonometric drawing of the basement along with its beam framework above it. The required service setups, namely a UGT having a capacity of 60,000 liters along with a fire-fighting static water tank with a capacity of 3,000 liters and a rainwater harvesting tank for 60,000 liters along with a pump room have been set up in the upper basement, which has been demarcated in purple. The AHU room has also been placed in the upper basement. The upper basement and lower basement each have a vehicular capacity of 127 slots of double stacks, zeroing down to a total of 254 cars. Piles of 600 mm diameter have been set up at a center-to-center distance of 3 meters each along with a raft foundation which is 2.1 meters deep with a pile height of 7.5 meters each. The basement and the podium are accessed using ramps that originate from the ground floor. They stand to be 2 one-way ramps of 4.5 meters width each at a slope of 1:10. Both the podium levels have a vehicular capacity of 121 slots of double stacks on each level, zeroing down to a total of 242 cars. For efficient vehicular movement, driveways of 6 meters have been designed wherever vehicular access is permitted. The 3 different representations, respectively, denote the axonometric drawing of the entire structure, which is followed by 2 sectional axonometrics, one through the lift lobby and the latter through the staircase block.